Good afternoon. Good afternoon, friends. Am I audible? Hello, guys. Please reply me. Am I audible to all of you? Thanks for your valuable reply. Okay. So yesterday we have already started with linked list, right? And how many linked list operations we performed yesterday? How many linked list algorithms we seen yesterday? Yes, linked list operations we performed yesterday into the list at which position? At last position. Then we also seen how to add node into the list at first position, and we also seen how to add a node into the list at specific position, in between position, that is in between position, right? Okay. Now today we'll start with deletion operation, right? Again, if you want to delete node, yes, we can delete node from the list by how many ways? Again, 3 ways. Delete node at first position, right? Then number 2, delete node at last position, and delete node at specific position, that is in between position, we can say specific, right? In bracket we can say, just a minute, in bracket we can say in between position, right? Okay, so we'll first see how to delete node from the list which is at first position, right? Now let me first show you the diagram of singly linear linked list, right? So diagram is in front of you. So there are 3 possibilities of singly linear linked list. Possibility number 1, linked list is empty. Possibility number 2, linked list may contains only 1 node, and possibility number 3, linked list contains more than 1 nodes, right? Now what do you think, what we should check first if you want to delete node at first position? What do you think, what we need to check first? If I want to delete node at first position, what we need to check first? Head check करना मतलब क्या check करना है? Yes, we have to check first list is not empty, right guys? So step number 1, very good. Step number 1, check list is not empty. If list is not empty, then only we can go for deletion of node, right? Do you agree with this? If list is not empty, then only we can go for deletion of node which is at first position, right? Now if list is not empty, then what are 2 different possibilities? Either list may contains only 1 node, or list may contains more than 1 nodes. Do you agree with this? But sir, how we can check list whether list contains only 1 node or not? Because if you see carefully, sir, if list contains only 1 node, and if we want to delete this node itself, then don't you think it is very simple? We can delete this node and we can make head as null. Are you with me, guys? Right? So if list contains only 1 node, then it will be very easier to delete that node and we can make head as null and list becomes empty, right? So here we can say, yes, step number 2. Can we say step number 2, if list contains only 1 node, then yes, delete that node and make head as, make head as null, right? It means, sir, here we can say if, but sir, how we can check whether list contains only 1 node or not? How we can check whether list contains only 1 node or not? Yes, friends. Are you getting what I'm saying? How to check whether list contains only 1 node? Diagram is in front of you. Yes, node nahi, head arrow next. Head arrow data, head arrow next. Head arrow data, head arrow next. Because head always contains address of first node. So how we can access data part of first node? Head arrow data. And how we can access next part of first node? Head arrow next. So if head arrow next is equal to null, yes, if it is equal to null, then what to do? Yes, in that case, what we have to do, guys? In that case, yes, let me write it in the comment form. Delete na, free karna hai hame wo, free head, right? That is, for example, hum isko kya pass kar rahe? Free 1000, right? It means we are passing this 1000 address, pay attention. We are passing this 1000 address to free function, due to which this memory gets released. Block of 8 bytes whose starting address is 1000 gets released. Hello friends, have you understood what I'm saying? So when I say free head, it means we are passing value of head. What is value of head? Value of head is 1000. So we are passing 1000. So due to which this memory gets released, and now we want to make head as, we need to make head as null in this case. right? And hence here we can say head is equal to null. Have you understood second step, guys? आपको second step समझ में आया क्या? Do you understood second step? Right? Now we can go to third step. We can go to the third step, right? So third step means else part. In else part, right? In else part, step number 3. अब बोलो step number 3 क्या रहेगा? Step number 3, sir, what if list contains more than one nodes? If list contains more than one nodes, right? So is this the case, friends? Is this the case, right? So diagrammatically speaking, अगर आप यहाँ पे आओगे, yes, सबसे पहले हमें यहाँ पे क्या चेक करना है? If list contains only one node, delete that node. But if list contains more than one nodes, hello guys, can you see this diagram? If list contains more than one nodes, is value of head is equal to null? Please reply me quickly. Is value of head is equal to null? No, it means list is not empty. Is step number 2, go to step number 2. Is head arrow next is equal to null? Is head arrow next is equal to null? No. What it means? It means list contains more than one nodes, and hence control comes inside else part. Control कहाँ पे आएगा? Control will come inside else part, right? Now it means in else part we have to think how we can delete this node. Yes. Now if we want to delete node at first position, don't you think current second node should become first node? Current second node जो है वो क्या होना चाहिए? First होना चाहिए, right? So can we say directly head is equal to head arrow next? Can we say directly head equal to head arrow next? It means हम लोग head की next की value store करेंगे, right? Sir यहाँ पे क्या आएगा? बोलो यहाँ पे क्या आएगा? If we are saying head equal to head arrow next, यहाँ पे आएगा 2000. यहाँ पे क्या आएगा? 2000, right? And what will happen, friends? This link gets break. And new link got created. ये link create होगा. This link got created. So sir, have we deleted node which is at first position? हमने node delete किया है क्या? No sir, this node is not yet physically deleted, and we lost the address of this node, right? 1000 address we lost from our program, and there will be a memory leakage. Are you getting, guys? What is the problem, right? So sir, हमें ये तो करना है. We have to do this. Store an address of current second node into the head, right? But if we directly say like this, what will happen? We'll lose the address of first node, so we cannot delete this physically. There will be a memory leakage, and hence here we require one temporary pointer. Hello friends, मैं undo कर रहा हूँ यहाँ पे. I'm doing undo here, right? Here we require one temporary pointer, right? So पहले क्या करेंगे? First store an address of first node into temp, which is to be deleted. Yes, deleted. Hello guys, it means we can say temp is equal to yes head. जो node आपको delete करना है उसका address temp में store करो, right? It means here we can say temp. We can store address of node which is to be deleted in temp, right? Now we can say head equal to head arrow next. यहाँ पे क्या आएगा अभी? 2000, right? And due to this, what will happen? This link has been created. ये link यहाँ पे create होगा. This link gets break. But sir, we have already stored its address in a temp, right? Now can we free this node? Can we delete this node? Yes. Now free the node or delete the node. Delete node, right? And here we can say free temp, right? और यहाँ पे क्या होगा? Yes, free temp. It means this node gets deleted physically. This node gets deleted. Memory gets released, and we have deleted node which was at first position successfully. Hello friends, have you understood this? आपको ये समझ में आया क्या? Right? So don't you think similarly, if I want to delete one more node, can I apply same logic again? We can apply same logic again. Store address of node which is to be deleted in the temp. Store address of second node into first head, and then delete the node. Right? It means we can delete all the nodes. From the list. Right? In how much time do we need to traverse? List in this case? No need to traverse, guys. हमें यहाँ पे traverse करना पड़ रहा है कि delete at first position delete करने के लिए? No, right? And hence here we can say, okay, just a minute. Let me copy this from here. मैं यहाँ से copy करके लेता हूँ for your information in this text file. Let me write it over here, right? Okay, so we can delete. What we can say? We can delete. Yes, all the nodes. We can delete all the nodes from the list, or from single linear linked list. Yes, in how much time? In order of one time. Or we can delete node which is at first position, we can delete node which is at first position, from singly linear linked list in how much time, guys? In order of one time. In order of one time. Only we can delete node at first position. और ऐसे वन बाय वन हम सारे नोड डिलीट कर सकते हैं, राइट? तो लेकिन फर्स्ट पोजीशन का नोड डिलीट करने के लिए डू वी नीड टू ट्रैवर्स? If we want to delete node at first position, do we need to traverse list? No. And hence delete first operation takes how much time? Delete first operation takes order of one time. Hello guys, have you understood this? आपको ये समझ में आया क्या? Right? Okay. Now can we move to the next function? Next function is, yes, delete node at last position. Delete node at last position, right? So name of algorithm is delete node at last position. Let me write the name over here, right? Again, don't you think if we want to delete node at last position, what we should check first? हमें पहले check क्या करना पड़ेगा? Again, diagram is in front of you. Again, we have to check first list is not empty, right? So step number one will want to remain same. Step number one will want to remain same, right? Now, if list contains only one node, and if we want to delete node at last position, don't you think this is the first as well as last node? Again, can we follow same step? Delete the node and make head as null. Hello friends, are you with me? Delete the node, delete node and make head as null. Step 2 also want to remain same, right? It means इसलिए मैंने यहाँ से copy किया, right? So first two steps are remain same. Only there is a change in third step. वो क्या देखते हैं, right? It means if I want to delete node at last position and if list contains more than one nodes, hello guys, so is value of head is equal to null? No, it means list is not empty. Is value of head arrow next is equal to null? No, it means list contains more than one nodes. And we want to delete node at which position? We want to delete node at last position. So sir क्या करें? Obviously we have to traverse list. Hello friends, we have to traverse list till, अब वो लोग कहाँ तक traverse करें? We have to traverse list till which node? Sir, can we traverse list till last node? Okay, pay attention. If we traverse list till last node, now you people know that how to traverse list. Trav equal to trav arrow next. ऐसे हम while trav arrow next is not equal to null, we can traverse list till last node by this way. Now, once we reach till last node, yes, what we supposed to do? We supposed to delete this node, right? And don't you think, guys, after deletion of last node, current second last node should become a last node? अगर आप लोग ये नोड डिलीट कर रहे हो तो जो सेकंड लास्ट नोड है वो होने वाला क्या होना चाहिए? लास्ट नोड चाहिए. एंड इट्स नेक्स्ट शुड पॉइंट टू, इसका नेक्स्ट क्या होना चाहिए? नल, राइट? ओके, इट मींस सर इफ वी ट्रैवर्स लिस्ट टिल लास्ट नोड, फ्रॉम लास्ट नोड कैन वी एक्सेस सेकंड लास्ट नोड? फ्रॉम लास्ट नोड कैन वी एक्सेस सेकंड लास्ट नोड? नो, फ्रॉम लास्ट नोड वी कैन नॉट एक्सेस सेकंड लास्ट नोड. हेलो फ्रेंड्स, आर यू गेटिंग व्हाट आई एम सेइंग? सर नॉट ओनली दिस, फ्रॉम सेकंड नोड कैन वी एक्सेस फर्स्ट नोड? फ्रॉम सेकंड नोड कैन वी एक्सेस फर्स्ट नोड? नो सर, ये सिंगली लिंक लिस्ट का लिमिटेशन है. इट इज लिमिटेशन ऑफ सिंगली लीनियर लिंक लिस्ट, राइट? सो व्हाट इज लिमिटेशन? Limitation of singly linear linked list is that yes, we cannot access previous node of any node from it. We cannot access, yes, previous node of any node from it. This is what limitation of singly linear linked list, and hence we have to traverse list till second last node. Hello friends, हमें last node तक traverse नहीं करना है, हमें second last node तक traverse करना है. Do you agree with this? So let me write else part over here. Right? So in else part, it means if list contains more than one nodes, अब लोग क्या करना होगा इस केस में? Yes, we have to traverse the list till second last node. Traverse list till second last node. But obviously हमें start कहाँ से करना पड़ेगा traversal? Start traversal from first node. We can start traversal from which node? We can start traversal from first node, and hence can we say trav is equal to head? Trav is equal to head, right? And so loop क्या use करेंगे? While trav arrow next. Hello guys, pay attention. So second last node के, pay attention. Second last node के next node का next part क्या होता है? Second last node के next node का next part always points to null, and hence here we are writing this line. So second last node के मतलब जिस node के next node का next part, जिस node के next node का next part null है, इसका मतलब currently trav is pointing to which node? Hello guys, currently trav is pointing to second last node, right? Okay, let me show you. Pay attention. We start traversal from which node? We start traversal from first node, right? Trav की वैल्यू कोई पता है मुझे क्या है? What is the value of trav? 1000. What is value of trav arrow next? What is value of trav next? 2000, right? Now trav arrow next, it means it's next. Trav arrow next, it's next 3000. So यहाँ पे compare क्या हो रहा है? 3000 is not equal to null. 3000 is not equal to null, right? It means by using this line, pay attention. By using this line, we are checking whether next part of its next node, मतलब current node के next node का next part null है कि नहीं, हम लोग ये यहाँ पे check कर रहे हैं. Trav arrow next, it's next. So if next part of its next node is null, it means currently trav is pointing to second last node, right? So trav का value 1000, trav arrow next का value 2000, its next is 3000. 3000 is not equal to null. Condition is 3000 is not equal to null. Condition is true. Condition is true, and hence control come inside while loop. Trav is equal to trav arrow next. It means trav will move to next node. Trav next node को move होगा. Value of trav becomes 2000. Value of trav becomes 2000, right? Again, value of trav is 2000. Trav arrow next. Trav arrow next का value 3000. It's next. 2000. It's next. 3000 का next is what? 4000. So next part of data which address is 3000. मतलब trav arrow next, it's next 4000. So the next part of its next one is null. Trav arrow next 4000 is not null. Condition is true, and hence again control comes inside while loop, right? Trav is equal to trav arrow next. Value of trav now becomes how much? Value of trav becomes 3000. Value of trav becomes 3000, right? Again, value of trav arrow next is what? Trav arrow next 4000. It's next 5000. It means is the next part of its next node is null? No, right? And hence this is not a second last node. 5000 is not equal to null. Condition is true. Trav is equal to trav arrow next, and hence trav will move towards its next node. Trav will move towards its next node, right? Again, control go for second next iteration. Again, value of trav is what currently, guys? Currently, what is value of trav? Value of trav is 4000. Trav arrow next is 5000. Its next is null. Hello friends, its next is null. It means if currently trav is pointing to this node, and if next part of its next is null, it means currently we are at which node? Currently we are at second last node. हमें इधर traverse करना है ना? Yes, and hence null is not equal to null. Condition is false. While loop gets break over here. यहाँ पे while loop क्या होगा? Break होगा. While loop gets break over here, right? Now, so from second last node, can we access last node? Second last node से last node access हो सकता है क्या? Yes. सर हमें देखो next से मिल रहा है last node का value, last node का address. So can we say delete last node? Delete last node. So can we say free trav arrow next? Free trav arrow next. It means we are passing value of trav arrow next. हम trav arrow next का value pass कर रहे हैं. हम ये 5000 pass कर रहे हैं. Free 5000, right? It means which memory gets released? Block of 8 bytes whose starting address is 5000 will get released. सर ये रिलीज करने के बाद second last node का next क्या होना चाहिए? Second last node का next part क्या होना चाहिए? Null. So how we can do this? Yes, we can say trav arrow next is equal to null, right? And hence we can say make next part of second last node as null, right? And hence trav arrow next is equal to null. Hello friends, have you understood this? तो यहाँ पे बोलो क्या आएगा? यहाँ पे क्या आएगा? यहाँ पे आएगा null. It means we have successfully deleted node from list which is at last position. In how much time? Sir, time कितना लगा हमें यहाँ पे? Yes, we have to traverse list till second last node. Sir, if list contains 100 node, we have to traverse list till node number 99. If list contains 1000 nodes, we have to traverse list till node number 999, right? It means it depends upon the size of the list. जितने number of nodes है उतने, right? And hence we can say here, pay attention. तो मैं ये जो else part है, यहाँ से copy कर रहा हूँ, right? Let me write it over here as well for your information, right? So this is the third step. So we can delete node which is at last position from singly linear linked list in order of n time. In how much time? Order of n time. Is this clear to all of you? आपको delete last समझ में आया क्या? Have you understood delete last? Right? Now can we go to the next operation? That is delete node which is at specific position. Delete node which is at specific position, right? Specific position. Yes, what do you think? What should be the first step? Step number 1. Yes, accept position from user. Accept position from user. ये पहला step है. right? Then step number 2, yes, let's say for example, pay attention, let's say this is our linked list. 1 minute, yeah, हमारा linked list है. And how many number of nodes are there, guys? 1 2 3 4 5 nodes are there, right? 5 number of nodes are there in the list, right? Now if I enter position at 6 for deletion of node, each 6 is a valid position. Is a 6 is valid position for while deletion? No, because only 5 number of nodes are there. So if I say delete node at 10th position, is a 10th is a valid position? No, it means valid positions are only from 1 to count 1 to 5, 1 to count, that is 1 to 5 in our example. मतलब जितने number of nodes रहेंगे वो क्या रहेंगे, valid position रहेंगे 1 to count. Hello friends, have you understood this? So either we can say delete node at first position or second or 3 or 4 or 5, 1 to count. Sir अगर 10 नोड होंगे तो 6 7 8 9 10, it means 1 to count, right? And hence let me write over here validate position, right? Now if position is greater than 0, or can we say greater than or equal to 1, it's up to you, and position is less or equal to count nodes, right? Then only we can say position is valid. Position is valid and go for deletion, go for, yes, delete node at that position, go for delete node at that position, otherwise print message, yes, invalid position. Hello friends, have you understood this step? Right, now step number 3, or here we can say then we go for delete node at that position, that is step number 3. Go for step number 3, right? So step number 3, it means control will come inside step number 3 only when control step number 3 पे कब आएगा, only if, yes, position is valid, right? Only if position is valid, right? So if position is valid, then only control come to the third step, right? Then here very first we have to check if position equal to 1. What it means? If position is the first position. Hello friends, do you agree with this? Sir अगर position first है, so do we need to write logic for again for it? Logic फिर से लिखे क्या? No. Give call to delete first function. Apply this algorithm. Give call to delete first. Else if position is equal to count nodes. What it means? It means if position is last position. If position is last position, what to do? Yes, give call to delete last. Delete last call karo. Else. So when control will come inside else part. Control will come inside else part if position is in between a position. Hello friends. Position is in between position. So control यहाँ पे आएगा. Right? Okay, so we'll try to understand this with a diagram. Let's say value of position is 4. Let's say value of position is 4. Right? So is position is valid first. Is it valid? Or either 4 or 3, you can take any value in between. Is 3 is valid position? Yes, 3 is valid, right? So sir, हमें क्या करना है? What we want to achieve? We want to delete this node. हमें ये node delete करना है. But if we want to delete this node, yes, current second and current fourth, मतलब position minus 1th and position plus 1th, this node should get connected. Hello friends, what is expected? Have you understood this? And then we can delete those node. Then we can delete this node. Right? So what we want to achieve, have you understood? If we want to delete this node, yes, then current second, that is position minus 1 and position plus 1 node should get connected, right? And hence we need to update next part of position minus 1 node. And to do this, we need to traverse list till I'm sorry. We need to traverse list till, बोलो हमें क्या करना पड़ेगा? Yes, traverse list till position minus 1th node. Traverse list till position minus 1th node. Now you people know that we can start traversal from which node? We can always start traversal from first node. We can always start traversal from first node. So we can say yes, trav is equal to head. Right? Now do you people know how to traverse list till position minus 1 node? Same logic which we applied while addition by using counter. Right? So here we can say while value of I is not less than position minus 1. बोलो क्या करेंगे यहाँ पे? I plus plus and trav is equal to trav arrow next. Hello friends, have you understood this logic yesterday? Right? So we can start traversal from which node? We can start traversal from, yes, first node. Right? Traversal first node start here. So what is the initial value of I? Initial value of I is 1. Initial value of I is 1, right? Okay, then control come over here. Trav start from here. Control आप आएगा. I का value क्या देखो 1. Position का value 3. Is 1 is less than 3. Sorry, 3 minus 1 ना. 3 minus 1. Is 1 is less than 2. Is 1 is less than 2. Yes, and hence control come inside while loop. I plus plus. Value of I becomes 2. Trav is equal to trav error next, and hence trav will move to the next node. Again, control go for next iteration. Is 2 is less than 2. Is 2 is less than 2. No, and hence trav pointer will remain here only. Trav यहीं पर रहेगा. Sir, is this the position minus 1 node? Is this position minus 1 node? Yes, and hence this loop can be used to traverse list till position minus 1th node, right? So traversal yaad aaya, right? Now what next we want to do? Yes, we need to connect second and fourth. We need to connect second and fourth, and then we need to delete this one, right? तो क्या करें यहाँ पे? Store address. Yes, हमें यहाँ पे temp लगेगा temp. Yes, आप लोग जो बोल रहे हो वो चलेगा. Trav next, equal to trav next. लेकिन we lose the address of this node. We will lose the address of this node, so there will be a memory leakage, and hence we require store address of node into the temp, which is to be deleted, right? And hence, or which is to be deleted. And hence, yes, what we can say over here, temp is equal to trav arrow next, right? So मतलब temp में किसका store करेंगे? We want to store address of node which is to be deleted in temp. Trav arrow next 3000. Temp is equal to 3000. So temp will start pointing to this node, right? Now can we attach? Yes, store an address of position minus 1, sorry, position plus 1th node into next part of position minus 1th node, right? It means, can we say trav arrow next is equal to temp arrow next? Hello friends, are you with me? So we can say trav arrow next equal to temp arrow next, or you can say trav arrow next is equal to trav arrow next, arrow next. Either this line or this line, दोनों का meaning same है. The meaning of both lines is same, right? And then we can say free node. Node delete करना है ना? Delete the node. Delete the node. How we can do this? Free temp, right? इससे क्या होगा देखो, pay attention. Yes, so trav के next में temp का next 4000. तो यहाँ पे क्या आएगा? यहाँ पे आएगा 4000. यहाँ पे क्या आएगा 4000, right? So due to this, what will happen? Due to this link has been created. ये link यहाँ पे create होगा, right? And then trav arrow next to temp arrow next होगा. Then we can say delete node, right? उसके बाद ये node delete होगा. Free temp, right? It means now this node will become third node, na? First, second, this will become third, fourth. It means we successfully deleted a node which was at third position. We successfully deleted node which was at third position. Hello friends, have you understood this? Have you understood this? So this is how we can delete node which is at specific position from singly linear linked list. Again, in how much time, guys? In how much time? Again, we have to traverse list, right? So it takes order of n time only. It takes order of n time only, right? So we can delete node which is at specific position from singly linear linked list in order of n time, right? So can we say here limitations of singly linear linked list? Yes, add last and delete last. Add last and delete last operations are efficient or not efficient? Are not efficient, as it takes how much time? Are not efficient as it takes, yes, order of n time. As it takes order of n time. ये उसका पहला limitation, right? Then what is second limitation? We cannot access previous node of any node from it. Then what is third limitation? Pay attention. Pay attention. If you start traversal list from first node, right? So यहाँ से traversal start करेंगे. Trav into trav arrow next. Trav into trav arrow next, right? Now once we reach to third node, can we revisit any node? If we go to third node, can we revisit first and second? Hello friends, can we revisit any node? Revisit मतलब हमने already visit किया, can we revisit? No, right? This is one more limitation of singly linear linked list, right? So we cannot revisit any node in it. We cannot revisit any node in a singly linear linked list, right? And hence to overcome, pay attention, to overcome this limitation, yes, singly circular linked list. has been designed. Hello guys, have you understood why singly circular linked has been designed? Because in singly linear linked list we cannot revisit any node, right? Then sir, what do you mean by singly linear linked list? Sorry, singly circular linked list. Singly circular linked list is exactly same as singly linear, only difference is in last node's next part. Only difference is there in last node's next part, right? And hence let me copy this definition as it is. Let me copy this definition as it is, right? And we'll write the definition of singly circular यहाँ पे, right? Different between second and third. अरे second में क्या देखो? In second we cannot access previous node of any node from it. ये इसका मतलब है. We cannot access previous node of any node from it. It means, sir, from last node can we access second last node? देविदास, from last node can we access second last node? Access की बात कर रहे हैं हम लोग, access की. No. From second node can we access first node? So इसका मतलब we cannot access previous node of any node from it. किसी भी नोड से हम उसके previous position नोड access कर सकते हैं क्या? No. ये second limitation है. Third limitation, sir, if we start traversal, let's say 1, 2, 3, if we reach till here, now if you want to again visit first node, is it possible? Can we revisit first node? No. Why? Because we can traverse only in a forward direction. अरे हम सिर्फ forward direction में traverse कर सकते हैं because each node contains address of only its next node, right? And we cannot revisit. तो आगे जाएंगे तो फिर डायरेक्टली क्या होगा यहाँ पे? Traversal होगा and traversal is finished. So can we revisit any node? No, we cannot revisit any node, right? And hence to overcome this definition, this limitation, singly circular linked list has been designed. Is that clear? Devidas. Okay. Now, sir, shortly repeat delete node in specific position. अरे अभी इसमें क्या है repeat करने के लिए? See, if I want to delete node at specific position, then what we have to do? Yes, we have to traverse list till position -1th node. Why? Because अगर आपको third node delete करना है, if you want to delete third node, so current second and current fourth node should get connected. Akshay, is that fine? If you want to delete node at third position, so current second and current fourth, ये दोनों क्या होने चाहिए? These two nodes should get connected, right? It means so second node के next में fourth node का address हमें store करना है. It means we need to update next part of second node. So second node का next part update करने के लिए हमें यहाँ तक traverse करना पड़ेगा. So we need to traverse list till position -1th node. इसीलिए मैंने यहाँ पे लिखा है traverse list till position -1 node. So once we traverse list till position -1 node, तो फिर क्या करेंगे? Yes. तो फिर क्या करेंगे? Yes. Then we can store address of node which is to be deleted in a temp. Temp में store करेंगे, right? And then second node के next में fourth node का address store करने के बाद हम लोग ये delete करेंगे. Is that fine? Is that fine, guys? So this function is what referred as, ये कौन सा function है? Delete node at specific position. Is that clear? पवन क्या repeat करना है one time? मैंने फिर से repeat किया ये. What you want to repeat for? पवन आपने पूछा था repeat करने के लिए, repeat हुआ ये, आपको और कुछ चाहिए क्या? हाँ ये हुआ ना अभी, delete node at specific position होगा ये repeat, right? Is that fine now? So delete node at specific position. आप लोग कौन सा भी specific position का node delete कर सकते हो इससे, right? Okay, now we are moving to the next type of linked list, that is singly circular linked list, right? So singly circular linked list is exactly same as singly linear में हम revisit कर सकते हैं sir? No. अरे इसीलिए मैंने यहाँ पे लिखा है ना, singly linear में नहीं कर सकते, in singly circular में कर सकते हैं.
सर हम क्या करेंगे, जो ट्रैवर्सल है ना हमारा, उसमें हम हमारी हेड की फिर से पोजीशन इंसर्ट करेंगे.
No, उसे revisit नहीं बोलते, उसे revisit नहीं बोलते. Revisit means what? Which is already visited and by traversing only once. हमें फिर से traversal start नहीं करना है. Are you getting what I'm saying?
Yes sir. लेकिन सर उससे हम वापस किसी भी पोजीशन में जा सकते हैं ना, ये पॉसिबल केस है, ऐसा बोल रहा हूँ मैं. मतलब
no, not possible.
थर्ड पोजीशन में जाने के बाद मैंने मेरे ट्रैवर्सल में फिर से हेड की पोजीशन डाली और फिर से मैंने फर्स्ट और सेकंड.
अगर तुमने ट्रैवर्सल में फिर से हेड की वैल्यू स्टोर की तो तुम्हारा सेकंड टाइम ट्रैवर्सल होगा, तो फिर उसे रिविजिट नहीं बोलेंगे. डू यू नो द मीनिंग ऑफ रिविजिट? रिविजिट मींस अगर वो ऑलरेडी विजिटेड है by traversing only once, right? हमने अगर traversal start किया तो उसे visit किया तो हम फिर से can we come back in a reverse direction? Hello, or from last node can we again come back to the first node anyhow? No. हम लोग last node से फिर से first node में आ सकते हैं क्या? No. Are you getting? तो हम उसे revisit नहीं कर सकते. Revisit का मतलब है traversal start किया एक बार और हमने उसे visit किया है and now we cannot revisit it. तुम जो बोल रहे हो सर ट्राव में फिर से हेड की वैल्यू, तो फिर वो सेकंड टाइम ट्रैवर्सल हुआ, वो सेकंड टाइम फिर से ट्रैवर्सल स्टार्ट किया आपने, उसे फिर रिविजिट नहीं बोलेंगे. इज दैट फाइन सौरभ?
सर
राइट, ओके. तो उसे फिर हम लोग रिविजिट नहीं बोलेंगे, राइट. सो दिस इज व्हाट लिमिटेशन ऑफ सिंगली लीनियर लिंक्ड लिस्ट, एंड हेंस टू ओवरकम दिस लिमिटेशन सिंगली सर्कुलर लिंक्ड लिस्ट हैज बीन डिजाइन्ड. सिंगली लीनियर, सिंगली सर्कुलर, exactly same, only difference is in a last point. Last node points to first node. So इसका मतलब last node के next में, next part of last node contains an address of yes first node. Hello friends, are you getting what I'm saying? ये सिर्फ difference है singly linear में and singly circular में. So if you check it diagrammatically, अगर आप diagram देखोगे, yes sir, is this singly circular linked list? Yes, whereas list is empty. Sir, is this singly circular linked list whereas list contains one node? Yes. Please check. Head always contains address of first node if list is not empty. Right? Each node has two parts, data and next. Data contains actual data. Next contains an address of its next node. And last node का next part में किसका address है guys? Last node, as there is only one node. So this is the first as well as this is last node. So इसी node के next में each node का address. First last node के next में first node का address. Hello friends. Have you understood this? आपको ये second diagram समझ में आया क्या? Right? Now, if you go to the third diagram, singly circular linked list, whereas list contains more than one node, please check. Head contains address of first node. First node contains address of second node. Second node contains address of third node. Third node contains address of fourth node. Fourth node contains of fifth node. And as this is the last node next part point to first node. Right? Now, in this linked list, if you start traversal, start from first node. Right? So 10 विजिट करेंगे, ट्रैव इक्वल टू ट्रैवलर नेक्स्ट. 20 विजिट करेंगे, ट्रैव इज इक्वल टू ट्रैवलर नेक्स्ट. 30 विजिट करेंगे, उसके बाद ट्रैव इक्वल टू ट्रैवलर नेक्स्ट. 40 विजिट करेंगे, 50 विजिट करेंगे. अगेन इफ वी से ट्रैव इक्वल टू ट्रैवलर नेक्स्ट, विल रीच अगेन टू फर्स्ट नोड. सो अगेन कैन वी रिविजिट? हेलो गाइस, हम लोग इसे रिविजिट कर रहे हैं क्या? यस, बाय ट्रैवर्सिंग ओनली वंस और बाय स्टार्टिंग ट्रैवर्सिंग ओनली वंस. सो लास्ट नोड से हम लोग फिर से फर्स्ट नोड पे आएंगे. अगेन कैन वी रिविजिट एनी नोड? यस, वी कैन रिविजिट एनी नोड. इज दैट फाइन गाइस? Hello, have you understood? अरे आपको ये समझ में आया क्या सिंगली सर्कुलर लिंक्ड लिस्ट? Why it has been designed? It has been designed to overcome limitation of singly linear linked list that we cannot revisit any node in singly linear, and hence in singly circular we can revisit any node. Is that fine? Hello guys, is that fine? आपको ये तीनों डायग्राम समझ में आएगा सबको? Right? But don't you think guys, still that one limitation remains sustained here as well. अरे यहाँ पे वो limitation रहता है. कौन सा limitation? So previous node of any node cannot be accessed from it. Previous node of any node. So first node, second node, third node. From third node, can we access second node? From third node, can we access second node? No. From last node, can we access second last node? No. Right? And hence, still in singly circular linked list as well. In singly circular linked list as well, these limitations remains there. Right? So limitations of singly circular. So इसका advantage क्या है? We can revisit any node. ये उसका advantage है. So but what is limitation? Limitation is, yes, number one, we cannot access previous node of any node from it. Right? And one more limitation, pay attention. Don't you think, sir, last node next part always contains address of first node. Right? It means even we are adding node at first position. अगर आप node first position में add कर रहे हो, don't you think in that operation as well we need to update next part of last node? Hello friends, are you with me? In singly circular linked list, even if you want to add or delete node at first position, so while adding or deletion of node at first position, we need to update next part of last node, and for it we have to traverse list in those functions as well. Add first and delete first, दोनों function में हमें क्या करना पड़ेगा? लिंक लिस्ट को traverse करना पड़ेगा, and hence add first, delete first, add last, delete last. All operations are not efficient. Is that fine? So addition and deletion operations are, yes, not efficient in singly circular linked list. ये limitation है. So what is one more limitation? We cannot traverse singly circular linked list in a backward direction. Hello friends, don't you think this will remain? अरे ये इसके लिए भी रहेगा ना singly linear के लिए. We cannot traverse singly linear linked list in a backward direction. Right? And hence to overcome this limitation, let me write this over here. मैं ये यहाँ पे लिखता हूँ. Right? To overcome these two limitations, to overcome above two limitations, Yes, doubly linked list. Doubly linked list has been designed. Hello friends, is this fine to all of you? So doubly linked list has been designed to overcome about two limitations. Let me write it more specifically, doubly linear linked list, right? So sir, what do you mean by doubly linear linked list? Let me write its definition over here. Yes, type number 3, doubly linear linked list. Doubly linear linked list. So can we say it is a type of linked list in which head always contains address of first node? Yes, this point will going to remain same. Now this point will change. Pay attention. Each node has how many parts now? Hello guys, each node has 3 parts. Sir, which 3 parts? Number 1, data part contains actual data of any primitive or non-primitive. Second one is pointer. Next contains an address of its next node, right? And number 3, yes, pointer part which is referred as previous contains an address of its previous node, right? And third point, last node points to null. Last node points to null, right? Or let me write in much detail. Next part of last node, and previous part of first node. अब बोलो क्या रहेगा इसमें? Contains or points to. Hello guys, points to null ना? Because first node के पहले कोई नोड होता है क्या? Is there any node before first node? Is there any node before first node? No. Is there any node after last node? No. And hence previous part of first node and next part of last node points to null, right? So ये है last point of doubly linear linked list, right? Now if you try to understand this with the help of diagram, can you see diagram guys? Please check possibility number 1, doubly linear linked list, whereas list is empty, head is equal to null, right? Then doubly linear linked list, whereas list contains only one node. So if list contains only one node, then we can say this is the first node as well as this is the, we can say this is the first node as well as this is the last node, right? So head contains address of first node, head always contains address of first node, right? Then previous part of first node points to, previous part of first node points to null. Next part of last node points to, next part of last node points to null, right? So sir, is this a doubly linear linked list? Yes, whereas list contains only one node. Now if you see diagram number 3, doubly linear linked list, whereas list contains more than one nodes. Please check, head always contains address of first node. Each node has 3 parts, previous, data, next. Data part contains data, previous part of first node points to null, right? Then first node, next part contains address of second node. Second node, previous part contains address of first node. Second node's next part contains address of third node. Third node, previous part contains address of second node. So each node, we can say, each node contains address of its next as well as its previous node. And next part of last node points to, next part of last node points to null. So sir, is this a doubly linear linked list? Yes, this is a doubly linear linked list. Doubly linear linked list, whereas list contains more than one nodes. Whereas list contains more than one nodes. Are you getting what I'm saying, guys? So what is advantage of this linked list? इस type के linked list का advantage क्या है? An advantage of this type of linked list is that yes, we can access previous node of any node from it. Say something like first, ये second, ये third, and this is fourth. So from second node, can we access first node? From second node, can we access first node? Yes. So from fourth node, can we access third node? Yes. It means previous node of any node can be accessed from it. मैंने यहाँ पे लिखा है देखो. We can start at last. Sorry, doubly linear linked list के advantages क्या है देखो? We can access previous node of any node from it. Are you with me, guys? Then one more advantage, we can traverse list in backward direction as well. We can traverse list in forward direction as well as in backward direction. Is that fine? Hello friends, is that fine? Right? So let me write over here advantages. Advantages of doubly linear linked list. Bolo kya advantages? Number 1, or we can say here, yes, we can access previous node of any node from it. First advantage, right? One more advantage, we can traverse, yes, doubly linear linked list in a forward direction as well as in a backward direction. Hello friends, so we can access previous one of any node from it. We can traverse list in a forward direction as well as a backward direction. right? So, but what are its limitations or disadvantages? Don't you think, guys, in this linked list, if you want to add a node at last position, अगर आपको last position node add करना है, we have to traverse list till last node, and then only we can make these links, right? Hello, guys, are you with me? Have you understood this? So if you want to add a node into the W linear linked list at last position, we have to traverse list till last node, and then we can add this node into the list at last position. So not only while addition, while delete last as well, we have to traverse list till last node, second last node or last node, whatever. But don't you think हमें traverse करना पड़ेगा? And hence here can we say that addition, or we can say add last, and delete last, add last and delete last functions are not efficient, are not efficient, as it takes how much time? Efficient as it takes, yes, order of 10 time. Hello friends, have you understood this limitation of doubly linear linked list, right? So uska और एक disadvantage है, yes, we can start traversal only from first node. अरे because हमें head से मिलेगा ना value इसका, we will get value of address of first node from head, so we can start traversal only from first node, right? And hence to overcome limitations of doubly linear linked list, yes, doubly circular linked list has been designed. Hello friends, are you with me? So to overcome limitations of doubly linear linked list, doubly circular linked list has been designed. Sir, what doubly circular linked list is? So let me write definition of it first, then we'll try to understand it with the help of diagram. So doubly linear and doubly circular is exactly same except change in the last point. Doubly linear and doubly circular are exactly same, only change is there in the last point, that is next part of last node contains an address of first node and previous part of first node. अब बोलो क्या रहेगा, first node के previous में contains an address of last node. मैं first node का previous बोल रहा हूँ. What I'm saying previous part of first node, right? So in a doubly circular linked list, next part of last node contains an address of first node, and previous part of first node contains an address of last node, right? Now we'll try to understand this with the help of diagram. Can you see the diagram, friends? Can you see the diagram? आपको diagram दिख रहा है सबको? So this diagram is for which type of linked list? This diagram is for doubly circular linked list. Pay attention. Possibility number 1, doubly circular linked list, whereas list is empty, right? Here we can say whereas list is empty, right? So is this a doubly circular linked list, friends? Is this a doubly circular linked list? Yes, whereas list is empty. Whereas list is empty, right? Then possibility number 2, friends, please check. Doubly circular linked list, whereas list contains only one node. So if we see carefully, guys, pay attention. Head always contains address of first node. So what is address of first node? What is address of first node? 1000. So is it there into the head? Yes, it is there into the head. So head always contains address of first node. Each node has 3 parts: data, previous, and next. Now as there is only one node, so can we say it is a first node as well as last node? As there is only one node, so can we say it is a first as well as last node? Yes. The first node के previous में किसका address होता है? Previous part of first node contains address of last node. तो इसी node का address उसके previous में. And as it is a last node के next में first node का address. Hello friends, have you understood this? So this is a doubly circular linked list, whereas list contains only how many number of nodes? Only one node, right? Now diagram number 3, doubly circular linked list, whereas list contains more than one nodes. Please check. What is the address of first node, friends? First node का address क्या है देखो? Address of first node is 1000, right? What is the address of second node? 2000. Third node का address 3000. Sir, last node का address. What is address of last node? 4000, right? So head always contains address of first node. First node का address is there into the head, right? Then previous part of first node contains address of last node. Please check. Last node का address 4000. So is it there into the previous part of first node? Yes, it is there into the previous part of first node. Then each node contains address of its next node as well as address of its previous node. and the last node's next part contains what? Last node का next part में क्या देखो 1000. So 1000 is address of first node. So next part of last node contains address of first node, and previous part of first node contains address of last node. Hello friends, are you with me? Right? So this is a doubly circular linked list, whereas list contains more than one nodes. Is that fine? So इसका advantage क्या है देखो इस linked list का? This linked list can be traversed in both directions, in forward direction as well as in backward direction. Agree with this? ये उसका पहला advantage. Second advantage, we can start traversal of this linked list either from first node. Why? Because address of first node will get from head, or we can start traversal of this linked list from last one as well. Sir, last one से start कैसे करेंगे? Because pay attention, head arrow previous, head arrow data, head arrow next. तो sir head arrow previous से हमें क्या मिलेगा? Always from head arrow previous we'll always get what? Reply me friends quickly. From head arrow previous we'll always get address of last node, and hence no need to traverse list till last node to get address of last node. Last node का address get करने के लिए no need to traverse it. Traverse करने की जरूरत है क्या? No need to traverse it. Hello friends, are you getting what I'm saying? Right? So either we can start traversal from first node, that is from head, or we can start traversal from last node, that is from head arrow previous. तो यहाँ से start करो या यहाँ से start करो. We can start traversal from any node. Right? So can we access previous node of any node from it? Can we access previous node of any node from it? Yes, because each node contains address of its next node as well as address of its previous node. Possible. Right? Now what about add last? So if you want to add node at last position, do we really need to traverse list? Do we really need to traverse list? No, because from head arrow previous we'll directly get address of last node. So last node का address मिलने के बाद we can attach this node to the last node, right? And this by this way. Hello guys, are you getting what I'm saying? By this way we can attach in how much time? In order of one time. In how much time? In order of one time. Same for deletion as well. And hence in doubly circular linked list, yes, what are advantages? Advantage is that yes, यहाँ पे मैंने लिखा advantages. Doubly circular linked list can be traversed in forward as well as backward direction. Add last, add first, delete last, delete first. Operations are efficient as it takes order of one time and are convenient as well. Traversal can be started either from first node or from last node. Any node can be revisited and previous node of any node can be accessed from it. So these are advantages of doubly circular linked list. So the most advanced version of linked list. ये linked list का सबसे efficient version है. Hello friends, and hence whenever we say linked list means by default which type of linked list? When we say linked list, it means by default doubly circular linked list. Hello friends, have you understood this? Have you understood this? Right? So we have learned array data structure, we have learned linked list data structure. Now we are in a state to differentiate between these two. Can we differentiate between these two, friends? Now we can differentiate between array and linked list. So point number one, array is static whereas linked list is dynamic. So I hope people know what do we mean by static and what do we mean by dynamic. It means during runtime we can add or delete nodes into linked list, right? So the size of linked list is not fixed. During runtime we can add or delete nodes into the linked list. Then second point, array elements can be accessed by using random access method, which is efficient than linked list elements, which can be accessed by sequential access. Hello friends, are you with me? Have you understood this? Have you understood this, friend? Right? Have you understood this? Second point. So array elements can be accessed by using random access method, which is efficient than linked list elements, which can be accessed by using sequential access. So array elements access क्या है? Faster, right? Then third point, addition and deletion operations are efficient on linked list than on an array. Addition and deletion operations are efficient than on array, right? So ये भी point of difference हमने पढ़ा, right? Then next point of difference, array elements get stored into the stack section, whereas linked list elements get stored into the heap section. ये भी एक difference है, right? Then one more difference, in a linked list, extra space is required to maintain link. Extra space is required to maintain link in a linked list, whereas in an array, as array elements get stored at contiguous locations, right? तो उसमें क्या होगा? Yes, no need to maintain link explicitly. right? Okay, yes, stack and heap, these are the two sections in main memory. Stack and heap, these are the two different sections in a main memory. तो main memory में array के elements stack section में store होते हैं and linked list के elements heap memory में in dynamic memory allocation. सज्जन कुमार, is this fine? अगर आपने डायनेमिक मेमोरी एलोकेशन पढ़ा है तो उसमें हमने पढ़ा कि डायनेमिकली मेमोरी गेट्स allocated from heap section. So static memory allocation for array elements, dynamic memory allocation for linked list elements. Is that fine? Is that fine, friends? Have you understood the difference between array and linked list? Have you understood the difference between array and linked list? Right? And here we are finished with data structure linked list. Right? Now we are moving to the next data structure, that is a stack. We are moving to the next data structure, that is stack. So guys, are you ready with stack now? Right? Okay, what is stack? Let us first try to understand what stack is, right? Okay, what is stack? Very first, stack, it is a basic. What is stack? Stack is a basic linear data structure. It's a basic linear data structure. Stack is a basic linear data structure which is a collection or list of logically related, again, similar type of elements, logically related, similar elements in which elements can be added as well as deleted from only one end, referred as. What that end is referred as top end. So I hope you people have understood definition. Hello friends, I hope you people have understood definition of stack. So it is a basic linear data structure which is a collection or list of logically related similar type of elements in which elements can be added as well as deleted from only one end, referred as top end. Right? Now one more important point, as in this list, element which was inserted last, or can we say added last, can only be deleted first. Hello friends. So this list works in which manner? So this list works in, yes, last in first out manner, right? And hence it is also called as yes, LIFO list. It is also called as LIFO list, or also called as first in last out. Hello friends, either we can say last in first out, or we can say first in last out. Is it done? Hello friends, is this done? So please let me know anyone having any doubt in this concept and definition of stack data structure. Right? Okay, very good. Now we can apply, pay attention, we can apply basic three operations. Onto the stack in how much time? In order of one time. In how much time? Guys? We can apply or we can perform, either we can say apply or we can say perform, whatever. We can perform, yes, basic three operations onto the stack data structure in how much time? In order of one time. Number one is push, number two is pop, and number three is pick. Right? So what do we mean by push? Push means to insert or to add, right, an element onto the stack. Yes, from which end? Onto the stack. From which end, guys? From top end. From which end? From top end. Right? So ये कौन सा operation हुआ? ये हुआ push operation. Right? Then what do we mean by pop, guys? To delete or to remove. An element from the stack, which is at, yes, top end. And what do we mean by pick? Pick means, yes, to get the value, to get value of an element which is at top end to get the value of an element which is at top end. Current नहीं, यहाँ पे current वगैरह ऐसा कुछ नहीं होता है. To get current element at top, to get the value of an element which is at top end. I hope you people have understood this. अगर आपको समझ में आया क्या ये? So we can perform basic 3 operations onto the stack in order of one time: push, pop, and pick. Right? Now we'll see these algorithms. Right? Step by step. So first we'll see algorithm number 1, that is push operation. Right? Now pay attention. If you want to go for stack, अगर आपको stack implement करना है, right? So can we use array, guys? Can we use array? Right? Okay. So what we can do here, we can define. हम लोग यहाँ पे क्या define कर सकते हैं? Array ले सकते हैं. Right? Now we know that array अगर लेंगे, let's say having size 5. If we take an array having size 5, how many bytes of block will get allocated for it? कितने bytes का block allocated होगा उसके लिए? 20 bytes. Right? Now we usually draw this block of 20 bytes in a horizontal manner. Usually we draw this block of 20 bytes in which manner? In a horizontal manner, right? So but can we draw it in a vertical manner, friends? Can we draw it in a vertical manner? Yes, not an issue, because it is just a memory representation. It is just a representation, right? So we are having array 0, 1, 2, 3, 4, 5. So that we're going to use this as a stack. अरे हम इस array को ऐसे क्या यूज करने वाले? We're going to use this array as a stack, like a stack. Are you getting what I'm saying? Okay, I'm sorry. यहाँ पे only these many elements. Stack size of array is 5. Hello guys, are you with me? Right? So this is an array. Right? This is an array. And this array we're going to use as a what? इस array को हम ऐसा क्या यूज करने वाले? As a stack. As a stack यूज करने वाले. Are you with me, friends? Right? Now, sir, stack. Sorry. Yes. Stack has which end? Stack has which end? Top end. And array has how many ends? Array has 1, 2, 3, 4, 5 indices, 5 ends. It means, sir, if you want to use this array as a stack, yes, we have to use a top either 0 or 1 or 2 or 3 or 4. So इसका मतलब value of top will be either 0 at a time or 1 at a time or 3 at a time and so on. Right? So इसका मतलब top का type क्या होना चाहिए? What should be type of top? Integer. Right? Integer, because का value क्या रहेगा? 0, 1, 2, 3, 4. Either किस कोई तो रहेगा, right? Now, can you please tell me, guys, what should be the initial value of top? Top का initial value क्या होना चाहिए? To indicate stack is empty. -1. Why -1? Because if we initialize value of top by 0, which will indicate that there is one element into the stack, right? Because in an array, 0 is a valid index or 0 is a valid position, right? And hence, if you want to use an array for stack, then initially we have to take value of top as -1. Hello friends, have you understood this? तो टॉप का वैल्यू इनिशियली क्या लेंगे? -1, राइट? सर ये टॉप का वैल्यू -1, व्हाट इट इंडिकेट्स? वैल्यू ऑफ टॉप इज -1, व्हाट इट इंडिकेट्स? स्टैक इज एम्प्टी. वेरी गुड, राइट? सो कैन वी से ओवर हियर, कैन वी से yes, if value of top is equal to -1, then we can say stack is empty. Hello friends, so stack empty, I can write like this: if value of top is equal to -1, I can say stack is empty. Right? We can say stack is empty. Right? Now we have to go for next operation, push. Why -1? Because अगर आप 0 लोगे, if you take 0, if 0 is a valid index in an array, yes, and which will indicate that there is one element. अगर आप top का value 0 से start करोगे, if you start value of top from 0, so it will indicate that in stack there is one element. लेकिन हमें initially stack क्या चाहिए? Initially we require stack as empty, and hence yes, initially we are taking value of top as -1. And one more reason, pay attention, one more reason, as we go on pushing element into the stack, so while pushing we need to increment the value of top by 1. अरे हम top का value क्या करेंगे? 1 से increment करेंगे, right? So obviously if you want value 0, so before incrementing it should be -1. हेलो गाइस, अगर -1 को हम 1 से इंक्रीमेंट करेंगे तभी वो 0 होगा ना? -1 को अगर हम 1 से इंक्रीमेंट करेंगे तभी वो 0 होगा, and hence the value of top should be initialized by -1, right? And if value of top is equal to -1, it indicates stack is empty. So what is stack empty condition? Stack empty condition is yes, if value of top is equal to -1, stack is empty. Right? Now if I want to push element into the stack, onto the stack, Yes, what do you think? What should be the first step? What should be the first step? Yes, very good. Before incrementing top by 1, don't you think, guys, there is an upper limit on the stack? Maximum how many number of elements we can push on the stack? In this stack, maximum how many number of elements we can push? 5, right? So don't you think before pushing element on the stack, we need to check whether stack full condition occur or not? Array stack should not be full, right? And hence step number 1 is check stack is not full. Check stack is not full, right? So if stack is not full, then only we can push element onto the stack. Hello friends, agree with this? And hence step number 1 must be, we have to check stack is not full, right? Now if stack is not full, then only we can go to the second step. Second step मतलब क्या करना है अभी यहाँ पे? Increment the value of top by 1, right? Then only we can say increment the value of a top by 1, right? It means value of top becomes, yes, what will be the value of top? 0, right? Now at top end, that is at 0th position, we can insert element. At top position, we can insert element, right? So we can say at this top position, element insert karo. So let's say 11 insert kiya humne. Let's say assume kar rahe any value of type integer, right? And hence we can say step number 3, push or insert. Either we can say push or insert or add an element onto the stack. At which position? At top position or top end, whichever word you can use. Insert or add or push an element on the stack at top end, right? So हमने यहाँ पे कौन सा element push किया है? 11 at top end. Hello friends, have you understood this? So लेकिन ये stack full का condition क्या होना चाहिए? Stack full. Hello friends, what should be the condition of stack full? Please check. ठीक है, एक काम करते हैं, वो condition बाद में लिखते हैं, right? We'll decide it later, right? But by diagram, can we say stack is not full? By diagram, can we say stack is not full? Yes, by diagram we can say stack is not full, right? Then what we can do? Yes, we can, if I want to push one more element on the stack, again follow algorithm. Step number 1, is stack is full? Is the stack is full by diagram? No, by diagram stack is not full. So can we go to the second step? Yes, we can go to the second step. If stack is not full, then only we can go to the second step. Second step is increment the value of top by 1. So sir, top का value क्या होगा? Value of top will become 1. Then third step, insert an element onto the stack at top position. It means at this position, at first position, we'll insert 22. Hello friends, are you with me? Now I want to push one more element on the stack. Again, step number 1, check stack is. अरे why 22? Just randomly value ले रहे हैं हम लोग यहाँ पे. ऐसे कुछ उसके पीछे रीजन नहीं है. So Einstein thinking की जरूरत नहीं है, right? Just for sake of convenience, I'm taking these values. 11, 22, आप यहाँ पे 10 लो, 20 लो, whatever, right? So just for sake of convenience, I'm taking these values, right? Okay. So I want to push one more element onto the stack. Step number 1, check if stack is full. Step number 1, if stack is full. No, stack is not full, right? If stack is not full, go to the second step. What is second step, friends? What is second step? Second step is increment the value of top by 1. Increment the value of top by 1. Are you with me? Right? So we need to increment the value of top by 1. हमें top का value क्या करना है? 1 से increment करना है, right? Okay, let's say just a minute. मैं ये यहाँ से cut करके यहाँ पे paste करता हूँ, right? So that we can just move this over here. Hello friends, are you with me? अपने कहा स्टैक में वैल्यू इंसर्ट करने का सिंटैक्स. अरे यहाँ पे सिंटैक्स क्या करेंगे? इंक्रीमेंट द वैल्यू. अपने सिंटैक्स नहीं पूछ रहा हूं मैं, अरे यहाँ पे हम लोग प्रोग्राम लिख नहीं रहे ना, वी आर नॉट राइटिंग अ प्रोग्राम, राइट? तो सिर्फ हम यहाँ पे क्या करेंगे? इंक्रीमेंट करेंगे इसका वैल्यू, राइट? और अगर इंसर्ट करना है आपको, तो हियर वी कैन से यस ARR ऑफ टॉप इज इक्वल टू एलिमेंट. ARR ऑफ टॉप इज इक्वल टू एलिमेंट. एट टॉप पोजीशन इन एन अरे हम लोग क्या इंसर्ट करेंगे? 11 इंसर्ट करेंगे. इज दैट फाइन? और यहाँ पे क्या करेंगे? टॉप प्लस प्लस. हियर व्हाट विल डू? यस, टॉप प्लस प्लस. इज दैट फाइन? सौरभ, इज दिस क्लियर? राइट? सो टू इंक्रीमेंट टॉप वैल्यू बाय 1, टॉप प्लस प्लस एट टॉप पोजीशन. अगर आपको एलिमेंट इंसर्ट करना है, सो ARR ऑफ टॉप इज इक्वल टू एलिमेंट. इज दिस फाइन? ओके. Now I want to push one more element. Yes, stack is not full. So second step, increment the value of top by 1. So value of top becomes 2, right? Then at top position, insert element at top position, let's say 33. Let's say 33 मतलब कौन सा भी वैल्यू हम इंसर्ट कर सकते हैं, right? Then सर ऐसे हम कितने वैल्यूज इंसर्ट करेंगे? We can insert two more values. So let's say 44 and 55 inserted. Now I want to push one more element onto the stack. I want to push one more element onto the stack. Yes, step number 1, check stack is not full. But by diagram stack is full. Yes, by diagram stack is full. So then what we can write condition? We can write condition if the value of top is equal to size minus 1. Hello friends. If value of top is equal to size minus 1, then we can say stack is full, right? So value of top, if it is equal to size minus 1, in this case we can say stack is full. So I hope you people have understood stack empty and stack full conditions. आपको ये condition समझ में आएगा, stack empty, stack full, and push operation as well. Now can we go to the next operation, that is pop? Can we go to the next operation, that is pop? Yes. Now what do you think? If you want to pop element from the stack, what we need to check first? We need to check first whether stack is not empty, right? So check stack is not empty, right? And hence we can say into the bracket over here, if stack is not empty, then only we can pop an element from the stack. अरे अगर stack empty नहीं होगा तभी delete करेंगे ना. So we cannot delete if stack is empty, right? So from which end we can pop element? From top end we can pop element, right? And we know that stack data structure works in which manner? Last in, first out. So which element was inserted last? 55. So which element should get deleted first? 55 should get deleted first. Then sir, before 55 which element was inserted? 55 के पहले कौन सा element insert हुआ था? 44. So after 55 which element should get deleted or should become a topmost element? 44 which should become a topmost element. And if you want to achieve this, we need to decrement the value of top by 1. Hello guys, are you getting what I'm saying? So if you want to achieve this last in, first out working manner, while popping we need to decrement the value of top by 1. And hence step number 2, decrement the value of top by 1. That is, yes, that is we are deleting or we are popping an element from the stack. अरे हम element कहाँ से delete कर रहे हैं? Stack से delete कर रहे हैं by means of decrementing value of top by 1. So just by means of decrementing value of top by 1, we are deleting the element from the stack, right? Okay, let us apply this over here. Pay attention. So let me write it over here. ये कौन सा algorithm है? This algorithm is, yes, pop. This algorithm is pop, right? This algorithm is pop algorithm, right? So ये कौन सा algorithm है? Push. So you people have understood what is push or how push works, right? Okay, how to check stack full or not? Please check यहाँ पे. If value of top is equal to size minus 1, we can say stack is full. अथर्व, यहाँ पे हमने condition लिखा है, right? Okay, now it means, sir, if you want to pop element, हमें क्या करना है? First check if stack is empty. By diagram, no, by diagram stack is not empty. Sir, by condition, is the value of top is equal to -1? No, by condition as well, stack is not empty. So we can go to the second step, decrement the value of top by 1. It means value of top becomes 3, and hence by means of decrementing value of top by 1, we have deleted, yes, 55 from stack. Our stack is only from 0 till top. Stack is only from 0 till top, and hence by decrementing value of top by 1, sir, हमने क्या achieve किया? We have achieved this deletion. ये 55 वहां से क्या हुआ हमारे stack से? We have pop element from our stack, right? So in stack now, how many number of elements are there? In stack, how many number of elements are there? Please reply me, friends. In stack, how many number of elements are there? Yes, 4 number of elements are there. Now if I want to pop one more element from the stack, yes, again can we apply same algorithm? Check stack is not empty. So by diagram is stack is empty. No, by diagram stack is not empty. By condition, is the value of top is equal to -1? No, by condition as well stack is not empty, and hence we can go to the second step. Decrement the value of top by 1. It means value of top now becomes 2, and hence in our stack only how many number of elements left? स्टैक में कितने एलिमेंट बचे अभी? ओनली 3. सो बाय मींस ऑफ डिक्रीमेंटिंग वैल्यू ऑफ टॉप बाय 1 वी आर डिलीटिंग दिस एलिमेंट फ्रॉम द स्टैक. हमें एलिमेंट क्या कर रहे हैं? स्टैक से डिलीट कर रहे हैं. सो टॉप मोस्ट एलिमेंट इज नाउ विच वन? टॉप मोस्ट एलिमेंट विच वन? 33. अरे टॉप मोस्ट एलिमेंट मतलब एलिमेंट विच इज एट टॉप पोजीशन 33, राइट? ओके, let me write pick operation as well over here. Sir, pick operation as well. If you want to pick element from the stack, we have to first check stack is not empty. So if stack is not empty, then only we can pick an element from the stack. And second step, yes, return the value of topmost element into bracket. Let me write without increment and decrement, without incrementing and decrementing of, without increment or decrement top. Hello friends, have you understood this? So while pick operation आपको top का value increment decrement करना है क्या? No, just to get the value which is at topmost position, that's it. So this is the third algorithm and it is very simple. It is very simple, only 2 steps are there, right? So if I want to pick element from the stack, yes, step number 1, check stack is not empty. By diagram is stack is empty. By diagram is stack is empty. No, by diagram stack is not empty. By condition is the value of top is equal to -1. No, by condition as well value of top is not -1, right? So sir, can we go to second step? Yes, return the value of topmost element, that is just return the value of 33 topmost element, that's it, without incrementing or decrementing top. Top को increment नहीं करना है, सिर्फ इसका value return करना है 33, that's it, right? Now if I want to pop one more element from the stack, can we pop one more element? Again, can we apply algorithm, guys? Can we apply algorithm? Yes, step number 1, check stack is not empty. So by diagram is stack is empty. By diagram is stack is empty. No, by diagram stack is not empty. By condition is the value of top is equal to -1. No, by condition as well stack is not empty, and hence we can go to second step, decrement the value of top by 1, right? And hence value of top becomes 1, and we have deleted, yes, one more element from the stack by means of decrementing value of top by 1. Yes, what we have achieved, we have deleted one more element from the stack. So sir 33 ऐसे क्या होगा? Delete होगा. So total how many number of elements are there in our stack right now? Only 2 number of elements are there in our stack right now. Are you getting what I'm saying, guys? Right now, don't you think similarly, yes, we can delete one more element from the stack. Similarly, we can delete one more element from the stack, and value of top becomes now what? -1. Value of top becomes -1. Hello friends, हमने 1 by 1 delete किए हैं वो. We have deleted elements 1 by 1. Are you getting what I'm saying, guys? If we say pop, so if we keep on popping elements, elements gets, or we can say here we can say, yes, if we keep on decrement value of top by 1, तो element एक से क्या हो रहा है? Delete हो रहा है 1 by 1. And finally, yes, finally value of top becomes -1 and stack becomes empty. Now can we further pop element? Can we further pop element? No. Sir, can we further pick element? Can we further pick element? No, right? Okay, Suraj Pathan, you are saying no need to free memory during pop. No, because it's an array. अरे array को memory कैसे मिलता है? For an array, how memory gets allocated? Runtime या compile time? सूरज, ये memory free नहीं होगा. Memory remains allocated. यहाँ पे dynamic memory allocation नहीं है, ये array है. Is that fine, सूरज? सूरज, is that fine, right? So यहाँ पे memory free नहीं होगा, right? Just by incrementing and decrementing value of top by 1, we are achieving operations, push pop operations. I hope it is clear to all of you. I hope these 3 algorithms clear to all of you. Is there any doubts, guys? Please let me know there is any doubt. किसी को डाउट है कुछ in stack? Okay, so can we move to the next point now? Sir, we can add any number of push in stack? No, we can add only maximum n number of elements, because array का size क्या है? Array का size क्या है, guys? Size of an array is 5. So as we are using this array as a stack, अगर हम ये stack as a ये array as a stack use कर रहे हैं, we know that stack has a limit, upper limit. So maximum how many number of elements we can insert into the array? 5, and hence into the stack. तो इस stack में भी हम लोग 5 से ज्यादा element insert और push नहीं कर सकते. Is that fine? हाँ, big number, yes. of type integer, you can insert or you can push any type or we can say any integer value onto the stack. आप integer type का कोई भी value इस stack में add कर सकते हो, push कर सकते हो, right? Because हम यहाँ पे array किसका maintain कर रहे हैं? Integers का. अगर आप यहाँ पे float का array maintain करोगे तो float type के elements का यहाँ पे stack होगा, right? Is that fine? Okay, in case of pick, no need of push or pop because pick operation का मतलब क्या है? Pick operation just to get the value of an element which is the topmost element, top end. आपको सिर्फ top element पे कौन सा value, top position पे कौन सा element है उसका value सिर्फ get करना है. That's it. अक्षय, while picking in pick operation आपको push भी नहीं करना है, pop भी नहीं करना है, आपको सिर्फ topmost element कौन सा है उसका value get करना है. That's it. इसे बोलते हैं pick. No need to push, no need to pop, just to get the value. And hence without incrementing and decrementing value of top हम लोग क्या करेंगे? पिक करेंगे, just value पिक करेंगे. That's it. So ये कौन सा data structure हुआ? This data structure is stack data structure, right? Now we are moving to the next point, that is applications of stack. Applications of stack data structure, right? Okay, so let me take you over here. So what are the applications? Sir, we can pick the element at middle. No, we cannot pick element at the middle. अरे यहाँ पे पढ़ो यार ठीक से, यहाँ पे क्या लिखा है? What do you mean by pick operation? Pick operation to get the value of an element which is at. Hardik Yadav, please read it carefully. क्या लिखा है वहाँ पे? To get value of an element which is at top end, only top end. We cannot pick element in between. Rather we cannot push as well in between any element. हम लोग बीच का भी कोई element push भी नहीं कर सकते बीच में और pop भी नहीं कर सकते, right? Only at top. That's it. Right? Because by concept. Why only at top? Because it's a concept of stack data structure. ये stack data का concept है. Okay, let me give you a real life example. कौन है ये? पवन. If you are maintaining stack of coins of 10 rupees, अगर आप 10 rupees के coins का stack maintain कर रहे हो, and if I give you one more 10 rupees coin, where you can insert that coin onto your stack? अरे अगर मैं आपको और एक coin दूंगा 10 rupees का उस stack में push करने के लिए, so you can push or you can insert that coin only at top ना? या तुम ऐसे बीच में कहीं पे भी push कर सकते हो? No, you can push or insert that coin only onto the top because that is stack of coins, right? Now if you want to pop element or pop coin, so you can pop only coin from the top end and not any in between other position. Hello, are you getting what I'm saying? If you go by concept, ये concept ही stack data structure का ये है ऐसे. So we can either push or pop or pick element only from top end. That's it. Is that fine? इसीलिए उसे stack नाम दिया है, right? Okay, sir, what are the applications of stack? Number one, stack is used by an operating system to control flow of an execution of a program. अरे आप जो अगर आपने execution of flow अगर देखा होगा, control get transferred from one function to another function, again from अगर nested call होगा तो again from that function to another function, and control of execution get back in a reverse direction, right? So इसका मतलब जो flow है execution का, this flow of execution of a program is maintained by an or is controlled by operating system by maintaining stack, right? आप लोगों ने पढ़ा होगा in C programming language, whenever any function gets called, its entry gets created onto the stack, and that entry is called as function activation record or stack frame. Function activation record or stack frame. So इसका मतलब ये by means of maintaining stack, what operating system does? Operating system controls flow of execution of programs. ये उसका one of the application. So what is one more application? In recursion, internally an operating system uses a stack. आप लोगों ने recursion पढ़ा है C में. In recursion as well, internally an operating system maintains stack. तो जैसे जैसे function recursively call होंगे, वैसे वैसे उनकी entries stack के ऊपर क्या होंगी? Function action record की entries push होती जाएंगी, and control will come back in a reverse direction exactly, right? Last in first order manner, and hence recursion. In recursion as well, internally operating system use what? Stack. Then number 3, undo and redo functionalities of an operating system are implemented by using stack. तो ये जो undo and redo functionalities है, right? Operating system की तो आप लोग use करते हो, right? Sir, these functionalities has been implemented by using stack, right? तो आप जैसे जैसे ऑपरेशन परफॉर्म करते हैं वैसे वैसे वो ऑपरेशन स्टैक में पुश होंगे, right? So if you want to say undo, yes, from stack that operation will be get popped और वो फिर से परफॉर्म किया जाएगा, right? So undo, redo, these operations can be implemented by an OS or in an OS by using stack. Then next application, stack is used to implement advanced data structure algorithms like DFS, depth first search. अभी आपको सिर्फ इसका नाम मालूम होना जरूरी है. You should know only name of this algorithm. DFS, depth first search algorithm in tree and in graph. सर ये algorithm implement करने के लिए which data structure is used? To implement DFS traversal, stack data structure is used. Remember this, right? And the last application, stack is used in an algorithms to convert given infix expression into its equivalent postfix and prefix, and for postfix expression evaluation, right? So ये जो algorithms है, in these algorithms stack is used. और ये algorithm मैं आपको सिखाने वाला हूँ. I'm going to teach you these algorithms, right? So can we start with the algorithm, friends? Can we start with these algorithms, right? So यहाँ पे expression conversion and evaluation algorithms, expression conversion and evaluation algorithms, right? Okay, पहला algorithm देखो कौन से algorithm है? Infix conversion of, let me write over here, conversion of given infix expression into its equivalent postfix expression or postfix, right? This is algorithm number 1. What's up? Very first, you should know what is an expression. Hello friends, what is an expression? An expression is, yes, it is a combination of an operands and operators. It is a combination of operands and operators, right? We can say there are, yes, an expression is, here we can say an expression is a combination of an operands and operators, right? There are 3 types of expressions. So which 3 types? Number 1, infix. Number 2, postfix. And number 3, prefix. Right? So for example, A plus B. So operator in infix expression, operator is in between 2 operands. Right? Then in postfix expression, operator is after 2 operands, AB plus. And in prefix, operator is before 2 operands. Hello guys, have you understood this? Basic example, have you understood basic example? What do you mean by infix? What do you mean by postfix? And what do you mean by prefix? Right? Okay, now we'll start with the first algorithm, conversion of given infix expression into its equivalent postfix. Right? So we are having first input with us. अब बोलो इस algorithm का input क्या रहेगा? Okay, before moving to algorithm, pay attention. Before moving to algorithm, first we'll check how to convert it on paper. अरे paper पे कैसे convert करते हैं वो देखते हैं, right? So let's say infix expression, right? Okay, I'm having, let's say, one expression with us, A star B divided by C into D plus A B C D E, right? Divided by F minus G, right? So sir, ये कौन सा टाइप का expression है? This is which type of expression? This is infix expression, right? Now, if you want to convert this expression into its equivalent postfix, yes, what we have to do first? We have to use Bodmer's rule. Very good, Ashwini. हमें कौन सा rule follow करना पड़ेगा? We have to follow Bodmer's rule, right? In which, let me write first, priority of multiplication operator, division operator, and modular division operator is higher. And तीनों का priority क्या होता है? Same. Priority of multiplication, division, and modular division operator is same, but it is greater than priority of, yes, addition, subtraction operations. Hello friends, have you understood this? And whenever, yes, if same priority operations are there, then yes, we have to go from yes, left to right. It means जो left का ऑपरेशन होगा वो पहले करेंगे, right? इसे बोलते हैं associativity, right? Left to right, yes. Okay, so are you ready, guys? Are you ready? What we want to do? We want to convert this expression into its equivalent postfix, right? So which operations are there? Multiplication, pay attention, multiplication, division, and subtraction. So which operation is having highest priority? Either this multiplication or this division or this multiplication or this division. But pay attention, but yes, as we go from left to right, we can perform first multiplication perform करेंगे. Hello friends, we going to perform first multiplication. So AB star, right? And I'm telling you the answer step by step. मैं आपको step by step बता रहा हूँ, right? So don't go so fast. ज़्यादा tension मत लो, right? I'm telling you answer step by step. So what is the result of first step? Result of first step is yes. Result of first step is this much. So A star B का result क्या मिला हमें? AB star. So this is the first term. This is the first term. अभी ये एक single term करके use होगा. Single term, first term, second term, third term, fourth term, fifth term, and sixth term. Now, which operations are there? Division between AB star and C. Multiplication between C and D. Right? Then division between E and F. So either we can perform division, multiplication, or division. But if priorities are same, then we can go from left to right. Hello guys, are you with me? We can go from left to right. So we can perform this division. Right? Sir, is division का answer क्या आएगा? Answer of this division is what? Yes, like this. Because this is the first operand. Please check. First operand, then second operand, and then an operator. Then an operator. Right? And rest of the thing will remain as it is. Because this is the result of this step only. अरे ये जो आपको दिख रहा है यहाँ पे, it is the result of second step. Right? Now this will going to be considered a single term. So this is the first term, second term, third term, fourth term, and this is the fifth term. Right? So which operations are there? Multiplication between AB star C slash and D, addition between D and E, division between E and F. So multiplication, addition, division, and subtraction. Which operation has got highest priority? Either multiplication or division. But as we go from left to right, we need to perform this operation, right? And hence, yes, operand 1, right? Operand 2, and then we can say an operator, right? So operand 1, operand 2, an operator, right? So these things will remain as it is. Hello friends, are you with me? Right? Now this will be considered a single term. ये as a single term consider होगा. Then second term, third term, and fourth term. Right? Then we can perform which operation? Division, because addition, division, and subtraction, division operation has got highest priority, and hence this operation takes place. ये operation होगा यहाँ पे. Are you with me, guys? Right? So what is the result of this? EF slash, right? So what about this one? This remains as it is. अरे ये यहाँ पे as it is रहेगा ना? This remains as it is, right? And इसके बाद यहाँ पे G as it is रहेगा. Hello guys, have you understood this? So this will become a first term. This is the second term, and this is the third term. Now addition, subtraction. Yes, as we go from left to right, so we can perform first addition of these two, right? So this is the first operand, right? Then this is the second operand, and this is an operator, right? And here we can say minus G. Hello guys, have you understood this? Minus G. And finally, yes, only subtraction is left over there. This is the first operand, first term, second term, and hence final answer is yes. Camilla, final answer. First term, right? Then second term, and then first operand, operand 2, and an operator. Hello guys, have you understood how to convert given infix expression into its equivalent postfix? Right? Okay. Now I'm telling you how to convert given infix into its equivalent prefix. Now again, algorithm remains same. मतलब process will remain same. Only instead of prefix, postfix क्या आएगा यहाँ पे? Prefix आएगा. Rest of the things remain same. Right? So in the first step, pay attention. In the first step, we'll take this as an input. Right? Okay, which operation has got highest priority? Multiplication, division, multiplication, division. But as we go from left to right, which operation we can perform first? Yes, we can perform first A star B. So इसका आंसर क्या आएगा A star B का? Answer of A star will be star AB. AB star नहीं, star AB because it's a prefix. Hello Pawan, please correct yourself. It's star AB because it's a prefix. In prefix, operator comes first, then operand 1, and then operand 2. Right? And rest of the things will remain as it is because we have find only first step answer. Right? Now we can perform this division. In second step, if you go from left to right, so division का आंसर क्या आएगा? Yes, यहाँ पे आएगा division operator. Operator comes first. Please check. Operator comes first, then first operand, and then second operand. Hello guys, have you understood this? Have you understood this step? आपको ये step समझ में आया क्या? देखो, we are performing this operation. Division operator comes first, then first operand star AB, and second operand C. Right? Then what next? yes, we can perform this multiplication. Now in this multiplication, yes, this is first operand, लेकिन operand one से पहले क्या आएगा? यहाँ पे आएगा operator. So operator, first operand and second operand, prefix, right? Then this will remains as it is. हम लोग ये as it is copy करते हैं, right? Now this is the first term, this is second term, third term, and fourth term. Which operations are there? Addition, division, and subtraction. So which operation we can perform, guys? We can perform division operation, right? So इसका आंसर क्या आएगा? Division का /EF. इसका आंसर क्या आएगा? /EF, right? सर ये जो पहले का था ये as it is रहेगा, right? So we find answer of this question over here like this. Answer of this step. So ये result of this step, right? Now we are having addition and subtraction. अब लोग कौन सा ऑपरेशन परफॉर्म करेंगे? Yes, we perform addition, right? So addition operator comes first, then operand 1, and then operand 2, then operand 2, right? बाकी एक्सप्रेशन as it is रहेगा. And finally this is the first term or first operand, then an operator and second operand, right? So can you please tell me, guys, what is the result, final result? Yes, ये जो minus है it will come at the beginning. Operator, first operand and second operand. Is this clear to all of you, friends? Have you understood how to convert given infix expression into its equivalent prefix and postfix? Right now, quickly pay attention. मैं आपको अभी बताता हूँ कि how, yes, given infix expression which is with parenthesis can be converted into its equivalent postfix with parenthesis. So अगर ये parenthesis होंगे, let's say a plus b, right, then c star d, और अगर यहाँ पे bracket होगा, yes, तो हम लोग क्या करेंगे? देखो यहाँ पे if, yes, let us first write this over here. If expression is parenthesized expression, अरे ये कौन सा expression है? Parenthesized expression. This expression is parenthesized expression, right? So if expression is parenthesized, then parenthesis has got highest priority. Hello guys, parenthesis has got highest priority, right? So sir ये perform कैसे करेंगे? Pay attention how we can perform it. Yes, in पहले हम लोग bracket solve करके लेते हैं, right? First we'll solve the brackets, inner brackets, right? So इसका मतलब यहाँ पे क्या आंसर आएगा? Yes, AB plus, right, /CD star. Hello friends, have you understood this? आपको ये स्टेप समझ में आया क्या? Have you understood this step? So ये जो ब्रैकेट है हमने ये पहले सॉल्व किया, AB प्लस, सर ये भी ब्रैकेट है C star D, CD star, राइट? अभी ये ब्रैकेट पहले सॉल्व करके लेंगे. It means yes, ये ऑपरेशन होगा. It means this much. अरे AB plus it is the first operand, CD star second operand, and / is an operator, right? And उसके बाद yes, this remains as it is. Hello friends, now there are no parentheses. तो जो हमने already follow किया था वही follow करेंगे, right? Now we can perform this division. We can perform this division, right? So यहाँ पे आंसर क्या आएगा? EF/. And what next? We can perform this addition, right? So if you want to perform the addition, yes, यहाँ पे क्या आएगा? यहाँ पे आएगा plus. And finally, yes, we'll want to perform subtraction. Hello guys, I hope you people have understood this. I hope you people have understood this. How to convert given parenthesized expression into its equivalent postfix, right? Remains applicable same for infix to prefix. तो आपको आप सिर्फ prefix करना होगा. Rest of the things are remain same. Is that fine, guys? Right? Okay, we'll do one thing. We'll wait here for we'll stop here for today, right? ये अगर हम लोग कल देखते हैं. We'll see this in tomorrow's session. Is that fine? So we'll stop here for today, friends, right? We'll see next contents in tomorrow's session, right? Thank you very much. Bye-bye. If you are having any doubts, so please, you can ask your doubts onto the WhatsApp group or Zoom channel, or you can get clear your doubts in the tomorrow's lab session, right?